Hey, what's up, guys? Not Dan here, ready to answer all of your questions concerning atoms. All right, so just hanging around, just waiting to see who's gonna come join us. Make sure that you've got your your target list, any of the questions that you've been working on, all your practice stuff. I got my paper back here, so I'm ready to work out some examples. If you have any questions, so just let me know whatever it is that you guys need. So up my chat window, and all right, so any questions that you guys have, I'm here. So I got my target list, I got my calculator, I got my paper. What questions do you guys have? What do you need? What do you need to know? I guess the first thing to go over, I guess, is the structure of the test, and really what all the different kinds of things that are going to be on there. So first and foremost, the test structure is going to be relatively the same as the last one. There will be 25 multiple choice questions that are 3 points each. So that's 75 points right there, leaving 25 points for the free response section. The free response section is going to have 5 different questions. One of them is going to be a chart where you are filling out the number of protons, neutrons, electrons, atomic mass, isotopic notation, all that good stuff. So nothing new there. There will be one energy, frequency, and wavelength calculation. There will be one average atomic mass calculation. And there's going to be an EDOT structure, which is ridiculously simple. And then there's also a Bohr model that you're going to have to draw. We'll give you an isotopic notation, and you simply have to draw the Bohr model based off of that. All right. So you guys have any questions? I see that a couple of you are logged on. So hey, what's up? But nobody's really said anything yet. So not sure if you want me to just kind of jump right on into the targets, or if you guys have any specific questions there for me. Not really sure. So just whatever it is that you guys want. That's why I'm here. So, all right. Well, since nobody's really typing in anything, I guess what I'll do is I will just kind of grab the target list here, and we'll just kind of go through some stuff. So on the front side of the target list, target number 1, use laboratory observations to confirm the presence of subatomic particles. You don't really need to worry too much about that one. That's a lab target. We dealt with that with the flame test that we did with that little demo. So you don't need to worry about that one. Target number 2, explain the electromagnetic spectrum in terms of the relationships between energy, wavelength, and frequency. All right. Hey, what's up, D? Can I give an example of an atomic mass calculation? I most definitely can do that. Average atomic mass. All right. So here's how it works. Okay. So for average atomic mass, there are 2 steps. Step 1 is to multiply. Step 2 is to add. Now, exactly what are we multiplying? Well, you're going to take the mass. So let's say, for example, we have an element that has a mass of 18, and the mass of 18 has a percentage of 23.4%. And let's see, it has a mass of 19 with, so whatever's left over of that, so it would be 56.6%. All right. So what exactly are we going to be doing with this? Well, we're going to multiply these 2 numbers together. And we'll multiply those 2 numbers together. We'll get those answers, and then we will add them up. And that's it. Okay. So the thing with this is that you've got to remember that this is a percentage. And so you got to move the decimal to the left 2 places. So what I'm actually going to be doing here is I will do 18 times 0.234, whatever that is. And then I'll do 19 times 0.566, and whatever that equals. Okay. So I will grab my calculator here. And if you guys have a calculator yourself, you might want to try this out right along with me to make sure that you know what you're doing here. Okay? Come on. Get some light going. Oh, this is awkward. Is there not enough light in the room? Oh, bother. I grabbed a calculator that does not work. That is ridiculously awkward. Come on, there's got to be enough light. Come on. Okay, we're going to go to plan B. I'm going to pull up a calculator here on my computer. We'll just kind of do it this way. It'll still work. All right. So I'm going to take 18 times 0.234. That comes out to be 4.212. And then I'm going to take 19. So 19 times 0.566. Oops. 19 times 0.566. And this comes to be 10.754. And then we're going to add them together. Okay? So I'm going to take the 10.754 plus 4.212. And we get 14.966. All right, now before we go any further, let's make sure that our number actually makes sense. Okay, and actually we can see very quickly that no, this does not make sense because, okay, I did something totally wrong somewhere. Okay, because our answer has to be between 18 and 19. So does this make sense? No. No, it definitely does not. All right, so I need to go back and kind of figure out what my mistake is. All right, so let's try that again. 18 times 0.234. 4 point. Oh, you know what my mistake is? This is embarrassing. This is not the right percentage. This is not supposed to be 56. This is supposed to be 76. Oh, that's awkward. Yeah, that's going to completely change that. So 0.766. So instead of 10 point, wow, I'm going to have to do this one all over again. I apologize for this. All right, so I'm going to do 19 times 0.766, and we get 14.554. See, and this is why it's important, though, to understand how to make sure that your answer makes sense, because otherwise I would have just kept going, written down the answer, and gotten it wrong because I wasn't paying attention. All right, so let's try this again. So 14.554 plus 4.212. What we get is 18.766. Does this answer make sense? Yes, it does, because the answer has to be between 18 and 19. And it has to be closer to the mass that has the larger percent abundance, which in this case is 19, and it most certainly is. Okay? And then what are our units for average atomic mass? Well, that is AMU. Okay? All right, so here's what I'm going to do. I'm going to give you another example. I want you guys to try to work this one out on your own, and I promise with this one, the numbers I give you will be correct. Okay, so let's say we have a group of isotopes where one of them has a mass of 23, one of them is 24, and one of them is 25. Okay, the mass of 23 has a percentage of, let's say, 89.2%. The mass of 24 has a percentage of 2%. Okay, so I'm gonna do a real quick, which means that the remaining percentage should be 8.5%. Okay, so what I want you guys to do right now is go ahead and try to work that out. Okay, so grab your paper pencil, grab your calculator, try to work that one out. I'll wait around for about a minute, and then I will work it out, and we'll check answers. We'll make sure that we know what's going on. Okay, All right, and then after this, yeah, we'll go into ions and isotopes. And we got another question. How did you get the answer for number 1 on the learning guide? I'm gonna have to get you to type in what that question is because I don't have a learning guide right in front of me, so I apologize for that. All right. So hopefully that's been enough time for you guys to try and work some stuff out. Okay, so what we're gonna do is 23 times 0.892, whatever that equals. Then we'll get 24 times 0.023. Remember, you got to move the decimal to the left 2 places. Okay, and then for this one, it will be 25 times 0.085. All right, so now we're going to multiply out 23 times 0.892 is 20.516. 24 times 0.023 is 0.552. Then 25 times 0.085 is 2.125. Now we add those all together, all right? So 2.125 plus 0.552 plus 20.516. What we get is 23.193. And does this answer make sense? Well, if we take a look at our masses, we have a range of 23 to 25, so it's got to be within that range, and it definitely is. And 23 has the largest percent abundance, so it must be closer to 23 than it is to any of the others, and it definitely is. So our answer makes sense, and our units are AMU. Okay, so that's how average atomic mass works. Okay, I don't understand what goes on the negative numbers on the isotopic notation. All right, so I will make sure to answer that question, D. While I'm also explaining ions and isotopes and all that good stuff, okay? So before I get any further though, I just kind of want to kind of establish what's going on this test. Because when you look at this target list, right, front and back, it looks like a lot, and I know it looks like a lot, but if you really stop and think about that, there's really not that much going on here, okay? You got your definitions. There's some vocab that you need to know. You need to know what an ion is. You need to know what an isotope is. You need to know valence electrons. And then there's energy, frequency, and wavelength, okay? You know me, I'm in your third period. Well, you know, I'm not even gonna. Okay. Anyway, so what we've got going on then is, so you got all those definitions, and then you've got your 2 calculations. You got your energy, frequency, wavelength calculations, and then you've got your average atomic mass calculations. That's it. Honestly, a good 70 to 75% of this test is just knowing your definitions of ions versus isotopes. And then the rest of it is just split between the 2 different types of calculations. Okay? All right. Okay, we don't need to be talking about clowns. All right, this is a safe environment right here. Okay, so Ariana says you got 2 for 25 times 0.085. Okay, well, I mean, you can see what here I've got 2.125. Okay, so I don't know, maybe your calculator doesn't go out that many decimal places. I don't know why it wouldn't. But yeah, 25 times 0.0825 is definitely not just straight up 2. So you might want to go back and check that. Okay. All right. So let's talk about ions and isotopes. All right. So ions are atoms that have a charge. That's basically it. Okay. And what that means is that it's either gained or lost electrons. And it's actually important to understand that right there. When an atom becomes an ion, it's all about gaining or losing electrons. Because when you gain or lose protons, what's happening is that you are actually completely changing the element. We don't typically change protons in an atom because it changes what it is. What we will change are what we're doing here is we're changing the electrons, which changes the charge, okay? And that's an ion. When you change the neutrons, what you're doing is now you have what we call the isotope, okay? And that just changes the mass, okay? So protons gives you a different element, changing the electrons gives you an ion, changing the neutrons gives you an isotope. That's what those definitions are. And then from there, it's just kind of understanding what information is being given to you when you read a particular question, okay? So like, for example, okay, let me pull this up here a little bit. Okay, let's say that we're dealing with, here, let's do one that just about everybody's familiar with. Okay, so here's an isotopic notation. This is oxygen, right? O for oxygen. What is this number on top? Mass number. How do you find the mass number? The mass number is protons plus neutrons. What is this number? The number on the bottom left is the atomic number. The atomic number is the number of protons, okay? So if I were to do a little chart where it was like protons, neutrons, electrons, like so, okay? Well, my atomic number here is the number of protons. So I had 8 protons, okay? Now the mass number is the protons plus neutrons. Well, I already know that there are 8 protons, so I'm simply going to subtract those two numbers. 16 minus 8 is 8 neutrons. Now, do you see a number up here? No, you don't. So therefore, the number of electrons and the number of protons are the same. So this will be 8 as well. But what if this said -2? Well, in this case, what this is telling us is that this atom is now an ion, and it gained 2 electrons. Now, how do I know that it gained 2 electrons? Well, remember, electrons are negatively charged. So if this charge is negative, that means it gained a negative, and therefore it now has 2 extra electrons. So instead of 8 electrons, it now has 10 electrons. That's what this means, okay? On the other hand, what if we take, okay, this is sodium. Sodium has an atomic number of 11. And let's say it has a mass number of 23 and a charge of +1. All right, we're going to do the same thing. All right, protons, neutrons, electrons. Okay, well, the protons comes from right here. That is 11 protons. The neutrons. So remember, neutrons is the mass number minus atomic number. So 23 minus 11 gives us 12. And what about the electrons? Well, the electrons here comes from our charge. Our charge is +1. If this was a neutral atom, it would be the same as protons, meaning it would have 11 electrons. But it has a charge of +1, meaning it has now lost. And therefore, it has 10 electrons. And a really easy way to check to make sure that you did that right is to go 11 minus 10. It's protons minus electrons. 11 minus 10 is +1. Up here, 8 minus 10 is -2. All right? Now, what if we had to draw a Bohr model for this particular ion right here? Okay? So I'm going to do my protons and neutrons. Here's my nucleus. Well, I have 8 protons. I have 8 neutrons, as we said over here. Now, it has 10 electrons. Remember, 2 electrons go in the first level. There's 2. And what's left over? Well, that would be 8 electrons. All right, well, let's check out this one. Okay, so let's do a Bohr model for this one. So 11 protons, 12 neutrons. It also has 10 electrons. So 2 electrons here, 8 electrons right there. Okay, so here's what I'm going to do now. I'm going to give you some more practice. Okay, I'm going to give you, let's see, chlorine, 17, 35, -1. Okay, so we got protons, neutrons, electrons, like so. So I want you to fill out or figure out how many protons, neutrons, and electrons there are, and then we will go through the Bohr model. Okay. All right. We got a question. So the -2 won't affect the mass? No. Yes. Good question, D. That the charge has no effect on the mass whatsoever. It is only the electrons that it deals with. Okay. Good question. Great question. All right. So how you guys doing on this? Think you got it figured out? All right. Let's try it. Number of protons comes from right here, 17. The number of neutrons is the mass number minus atomic number. So 35 minus 17 is 18. Okay, what about the electrons? Okay, well, it has a charge of -1. So if it has 17 protons and an extra electron, that gives it 18 electrons. Does the charge affect the neutrons or electrons? Okay, good question, Mac. The charge only affects the number of electrons. Okay, remember the neutrons are neutral, right? They have no charge. So if you're changing the charge, then that's definitely not affecting the neutrons any way, shape, or form. Okay, so it's all about protons and electrons when you're looking at the charge. The charge is protons minus electrons. Much like we've got here, the charge is -1. So 17 minus 18 gives you -1. The fact that the protons and neutrons are different here really doesn't mean anything. It just means that it's just a different mass. Okay, that's all that is. Okay, now if we were to draw a Bohr model for this one. Okay, so protons and neutrons. There are 17 protons, 18 neutrons. In the first level, we have 2 electrons. In the second level, here's 8. That's 10 electrons. I'm kind of running out of room here. So we'll have 8 more right there. All right. Now, I want to give you a little hint right here, special just for you because you are logging into this live stream. I ask you to draw the Bohr model for an ion, meaning it has a charge. So I'm not talking about neutral atoms here. If you are drawing the Bohr model for an ion, wink, wink, because you will. Okay? So when I ask you to draw the Bohr model for an ion, the energy levels must all be full. Because remember, that's the whole point of why an atom becomes an ion in the first place. It's trying to get a full valence shell. Meaning, you figure out however many energy levels it's got to have, and then they're all going to be full. You don't even have to stop and think about it, right? You got 2 electrons here, 8 there, 8 there. That's how it's going to be, okay? Think back to previous 2 examples we did. Check it out. Full, full. Ions have full valence shells, okay? So when I ask you to draw the Bohr model for an ion on the test, they're going to have a full valence shell, okay? So just a extra little something just for you guys because I like you so much. Okay, so we got another question here. How would it look like on the E dot structure? Excellent question. And you know what I'll do is I'll go back here and we will do that for every single one of these. Can an isotope be an ion? Yes. The terms isotope and ion are not exclusive. Wait, or are they? Yes, I'm sorry. They're not connected. They are exclusive. Sorry, I said that backwards. You can have an ion that is also an isotope. You can also have an isotope that's neutral. Okay, you can have an ion that that has the same number of protons and neutrons. Okay, so ion and isotope are not connected terms. They're completely exclusive. You don't need to don't get confused by seeing both of those. That's why on the quiz, those last couple questions, actually there was one question that was, which of these pairs is an ion and an isotope? Because they don't necessarily mean the same thing. Okay, two atoms that are isotopes just means that they have a different mass. They have different masses. And then if you've got ions, that just means that they have a charge. So charges and masses do not go hand in hand. You don't have to have one just because you have the other. Okay, I hope that makes sense. All right, so let's go back and do some do the E dot structures. Okay, so for this one, this is oxygen. So hopefully, oh, yeah, you guys can see this. So you do the symbol, and then you do. Actually, you know what? Now that I think about it, I'm going to stop myself before I really confuse you. Because remember, I told you guys specifically I would not ask you to do E dot structures for ions. So hold on. Now that I'm actually thinking. All right, I'm going to do something else. All right, so if I asked you to draw the E dot structure for something like, so what I'm going to do is I'll give you the same elements, but these are all neutral. Okay, these are neutral. So what you'll do is you'll realize, okay, so if there's 11 protons here, that means that there are 11 electrons. Okay, and you can even draw a Bohr model to help you out with this if you need to. Okay, but if there are 11 electrons, there'll be 2 in the first level, 8 in the second level, so that makes 10, leaving 1 left over, 1 valence electron. So I'm going to draw the symbol and then put 1 electron. Okay, if we did oxygen, so oxygen is 8 and then 16. Okay, so I'm going to put the symbol here. And so oxygen has 8 electrons, right? Because there's 8 protons, so 8 electrons. So 2 in the first level, leaving 6 to go into the second level. So I'm going to put 6 dots. 1, 2, 5, 6. Okay, it's really that easy. Okay, another way that you can do it, because I will have periodic tables available for you. I very unwisely left my periodic table at school. I just kind of grabbed my stuff and left, so I don't have one to show you. But I'll give you a periodic table on the test. What you need to do is you just look up where that element is on the periodic table, and the group number, that number at the top of the group, that is the number of valence electrons, and so then that's also the number of dots that you're going to have. Okay, like for example, if I give you, let's say it's carbon 14, like this. Okay, well, carbon is in group 4, so I'm going to put the symbol, which is C. I'm going to do 1, 2, 3, 4 dots. Okay, and just to answer a question that I'm pretty sure is going to be coming up, you don't have to put them all around like this. I could do it like that. I could also do it like this. Okay, the position of the dots are not what's important here. What's important is the correct number of dots. And remember, the dots represent the number of valence electrons. Okay, so very good. Do you guys have any other questions concerning ions and isotopes at this point? Because that's essentially all this is. Sorry, my throat's getting a little dry. Very cranberry soda here. Homemade, by the way. I explain about moles. Yes, of course I can explain about moles. Okay. So here's the thing. Moles is a concept that we're going to hit pretty hard second semester. So right now we're just kind of it, just so that you're kind of sort of familiar with the concept before we really get into a second semester. You don't have to know too much about what moles are and really what we do with them. All you got to know is that 1 mole is equal to 6.02 times 10 to the 23rd of, okay, usually we use them to count atoms and molecules, okay? But the important thing, though, is not really so much that you memorize this number, but that you understand the relationship between average atomic mass and molar mass, the mass of 1 mole of atoms. Okay, and that relationship is that you take whatever mass you see on the periodic table, because remember, it's not mass number. What you see on the periodic table is the average atomic mass. And you know how the units for average atomic mass are AMU. Well, then what you do is you drop the AMU and you stick on grams, and now you have the molar mass, okay? So questions that you might see would be something like this. Trying to think of something on the periodic table that I know pretty well. Okay, let's say, okay, so the molar mass of carbon, I mean not carbon, so chlorine. The molar mass of chlorine is 35.5 grams. So if the molar mass of chlorine is 35.5 grams, then what is the average atomic mass of chlorine? It's the same number. It's 35.5 AMU. That's all that is, okay? And that is the extent of what you will need to know as far as moles, okay? Yes, I will do, okay, more examples of what, Trinity? Are you talking about examples of the ions and isotopes, like the numbers, the Bohr models, E-dot structures, what? Okay, so I will get into energy, frequency, wavelength calculations. I will definitely do that. I will answer that specific question, but first I'm going to answer Mac's question, because there's a very simple answer to that. So she's asking the scientists that we learned about, should we review for them? And the answer is no. I mean, let's be honest. The scientists were important, and they did great work, and they got us to where we are. But we're a chemistry class, we're not a history class, okay? So I'm not trying to undermine their importance, but that is not the focus of what we're doing. And yes, it is a target, but if you'll notice, we assessed that target on the first quiz. And so we pretty much got what we need to know about your understanding of who the scientists are and what they did. And so we will not be testing about them on the test. So good news. So you do not need to waste any time memorizing their names and what they do, okay? So good, 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 good. All right, so more E-dot structures. Okay, so here's what I'm gonna do. Since I'm already doing E-dot structures, I will continue with more examples of E-dot structures, and then we will shift gears and we will answer questions about energy, frequency, and wavelengths and those calculations. Okay, and then once we do that shift, that pretty much should here as far as our review here. Okay, so more examples of E-dot structures. Okay, so let's say I give you this isotopic notation. Let's see. Okay, so I'm going to give you a couple of them here. And okay, so we're going to take these three and we're going to draw Bohr models for them. So first, if you have a periodic table with you, it's very easy to figure this out. Beryllium is in group 2, is in group 5, and neon is in group 8. Okay, so all you got to do is 2 dots, 5 dots, 8 dots. Or what you can do is you can see, all right, so I have, wow, That's 4, and that's 9. Sorry, my apologies. This is what you try to do when you make up stuff on your own without your reference stuff in front of you. Okay, so what I told you was true. This is this is 2 dot. What I was thinking is group 2, and that's why I wrote that 2 there. So it has 4 protons because it has an atomic number of 4, but there are 2 electrons in the first level, leaving 2 in the second level, so that's 2 valence electrons. And so our not Bohr model, our E dot structure is the symbol with the 2 dots. Okay? All right. Then for nitrogen, 7 protons, so 2 in the first level, leaving 5 shell. So we've got the symbol with 1, 3, 4, 5 dots. And again, you can put those 5 dots as long as, remember, you can only have 2 per side, right? If you were to imagine that there's a square around it, you can only put 2 dots. Okay, meaning the maximum number of dots is 8. Okay, so here, neon has 10 protons, so it'll have 10 electrons, 2 in the first level, 8 in the second, so that's 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And here's just another little bonus for those of you that are logged in and are watching this live stream. Show you the most common mistake that I see on the test. Okay, because this right here, these are easy points. Do not give these points away because this is ridiculously easy. But here is the most common mistake I have seen about E dot structures. Okay, let's say I give you the isotopic notation for fluorine, and fluorine is 9, and let's say it has a mass of 19. There are 2 different ways I have seen this mistake. First one is this. So, can you tell what's wrong with this? Count how many dots there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Done here is they have put the number of dots for all of the electrons that fluorine has, right? Because it has 9 protons, therefore 9 electrons, and so they put 9 dots. Why is this incorrect? Because the dots are supposed to represent the valence electrons, all electrons. Okay? Mistake that I have seen with this. You like this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 dots surrounding this symbol. And why do you think they did 19 dots here? Well, because they looked at this number right here and said, oh, therefore that's how many dots there should be. And they just started putting dots everywhere. No. The maximum number of dots you can ever put on an E dot structure is 8. Why? Because the most valence shells fill out and max out at 8. Okay, so what is the correct E dot structure for fluorine here? Well, if there are 2 electrons in the first level, that leaves 7 electrons for the second level. And so this E dot structure should only have 7 dots, like so. And that is the correct E dot structure for fluorine. Okay, so I hope that answered your question. Okay, we've only got about, I don't know, 15, 20 minutes left at the most to continue here. So I am now going to switch over to energy, frequency, and wavelength and answer all the questions concerning that. Okay, so real quick, if you guys remember, here's my amazingly awesome drawing of the electromagnetic spectrum. So we have energy, frequency and wavelength. Okay. So you need to remember the direction in which all of these increase. Okay, so energy increases in this direction. Frequency increases in this direction. Wavelength increases in the other direction. So what are the relationships between these values? Well, you can see that frequency and energy go in the same direction. These are direct. There's a direct relationship between energy and frequency. Between energy and wavelength, they go in opposite directions. Therefore, this is inverse. And the same thing for frequency and wavelength. They go in opposite directions, and therefore they are inverse. Okay? Now, if you are smart, and by that I don't mean you have this memorized and you do well on tests. When I say smart, what I mean is if you are clever and if you have very good test-taking skills, okay, like you're observant on the tests, you will be able to find the answer to these types of questions somewhere else on the test. If you are paying attention, answers to this can be found in the other questions. Okay, so you can either memorize this or you just go searching for it somewhere on the test. Wink, wink, nudge, nudge. Okay, all right, now when it comes to the calculations, do not waste any time memorizing the equations or memorizing the constants. They will be given to you. Because you got to remember our purpose in giving you this test. We are not trying to see how much just random information you can cram into your brain. We are interested in your ability to use the information that we have given you. Okay? So in other words, we are interested in how you can apply this information. Okay? So yeah, we've got the equations C equals F times lambda, and energy equals frequency. Or sorry, I have that written backwards from what you guys have seen, but I mean it's the same thing. Okay, so these are the two equations. They will be given to you. You will also be given that C is 3.00 times 10 to the 8th. You will be given that H is equal to 6.63 times 10 to the negative 34th. They will be printed at the top of the test. Okay, so before question number 1, you'll be given this information. You just need to remember that it's there and to actually use it. Okay, so before I do any specific calculations with these, I'm going to point out something that I hope that you can do this. Is there a way to calculate without a calculator? Yes, there is. It's a little more difficult, and I can show you. Should you memorize the units? Yes. Yes, you do need to memorize the units. Okay, the units will not be given to you. Okay, because that's a part of being able to apply it. Okay. And remember, you can always go back to one of the tutorial videos that I've already made and already shared with you guys, where I go over both of these equations, what everything means, what all the units are, so you can hear all of that. And then the very next video that I have, I go through, I believe it's 3 different examples. And so you can see me working it out. You can hear my thought process as I'm working it out. And hopefully you can then kind of apply it. But here's the thing. If you've been paying attention when you did all those calculations, hi, Graham. Yes, when the assignment we gave you was a little lengthy. okay, there were 15 calculations for you to do. And yeah, you will, it kind of seemed like a little bit of overkill. But we did that intentionally because we were hoping that you would pick up on the pattern of what was going on. Okay, yes, Jason, you will be given a calculator because remember, I've got that class set in my room, okay? So here's the pattern. When you are using this equation right here, this first one, let me bring this up a little bit more. You will do literally the same thing every single time. It does not matter if I give you frequency or if I give you wavelength. You will literally do the same process every single time. And here it is. You will always take C, which is 3.00 times 10 to the 8th power, and you'll always divide it by whatever number is given to you every single time. 3.00 times 10 to the 8th divided by the number given to you in the question will always give you the answer that you need. Okay? And if you don't believe me, go back and check the practice that we did on this. Look at all of those questions and see if what I've said is true. It's always 3.00 times 10 to the 8th divided by the given. Okay? Now, on the other equation, if you are searching for energy, so I'm giving you frequency, well, then you're just going to plug it in and you just do it like this. Frequency times the 6.63 times 10 to the negative 34th. You'll multiply those two together and you will always get energy. Okay? If you are looking for frequency, okay, well, then here's what you're going to do. It is always the number that's given to you, which is energy, divided by 6.63 times 10 to the negative 34th. And that's if you are looking for frequency. Single time. Okay, and again, go back and check the practice. This is the pattern. Okay, these conversions, and I understand why they can seem a little intimidating and they can seem like they're really difficult. Trust me, I get it. I understand why some of you are having a problem with these calculations. So that's why I'm pointing out these little tricks. These are the patterns that I want you to notice. And once you recognize those patterns, you're gonna see the same thing over and over and over again. And suddenly these calculations become a piece of cake because it's just straight muscle memory as you do the same thing as you type stuff into the calculator. Okay? All right, so let's get into an example. Okay, because we got one that was asked previously. It said, what is the frequency of light having a wavelength of 4.50 times 10 to the 8th meters? Okay, and then, oh, and then we got the answer there. How did I get that? Okay, so in that question, it's asking for frequency and it's giving you wavelength. This equation. And as I just pointed out, this is what we're going to do. We're going to do 3.00 divided by the number that you gave to us, which is 4.50 times 10 to the 8th power. Okay. All right, so then what we do is we type in 3.00. Okay, and now remember, on our calculators, the calculators have, of course, unfortunately, this one doesn't seem to be working. I don't understand why it's not working. That is really, really awkward. Okay, but anyways, so on this calculator, there is this EE button right here above the 7. This is the button you hit instead of times 10. Okay, so what you will type in is 3. Man, I really wish this calculator worked. I don't get it. Wait. Aha, magic. Come on, come on. Oh, it wants to work. It wants to work. I think I got it. I think I got it. All right. So 3.00 EE to the 8th power, and it's really light on here because the calculator's kind of being weird, so you can't really see it on my screen right there. But so what you type in is 3.00 EE8, and then I'm going to divide by the other number, 4.50 EE8, and when I hit equals, okay, and I'm actually going to correct your answer there. You're almost correct, but you're not quite correct, okay? Because the answer that you get, come on, this equals 0.67. So it's not 0.67 times 10 to the 15th, okay? It's just 0.67, okay? And since we are looking for frequency, the units are hertz. Okay, so let me do, what's the best calculator to use besides the test? I'm not sure I understand what that question means. What's the best calculator to use besides the test? I guess any scientific calculator that's got that EE button is probably the best. The calculator that you have on your phone most likely is not going to have that feature, and so it makes scientific notation a little more challenging. Okay, all right. So since we're kind of coming up on the hour mark here for this review, I'm gonna try to make this quick. Kind of wrap up here. So let's use this other equation here. Let's say that you have a frequency of 6.82 times 10 to the 4th hertz, and we want to know how much energy that is. Okay, so that's frequency going into here. So what I'm going to do is I'm going to take 6.82 times 10 to the 4th, and I'm going to multiply it by h. Remember, this number will be given to you on the test. So 6.63 times 10 to the negative 34th. Okay, and so then what we type into the calculator here is 6.82 EE4 times 6.63 EE negative 34. And then what we get is 4.52 times 10 to the negative 29. And this being energy, units are joules. Okay? So what I'm going to suggest here, instead of me just doing a whole bunch of examples over and over and over again, what I'm going to suggest is, number one, go back into your practice that you've done for this. Hopefully this is in your spiral notebook so that you got it. Go back in there and pick out some of the ones that you were having trouble with. Okay? Try to work them out again. If you can't, for whatever reason, it's just not working, come in tomorrow, because tomorrow's review day in class. Come in with those questions, and I'll be able to work them out with you. Here is my second suggestion. Go back onto my YouTube channel. Go find the video on the energy, frequency, wavelength calculations. Okay, not the one that goes over the equations, the one that's over the calculations. Okay, go back and watch that. In that video, there are 3 specific equations or calculations that I go over. When you see the equation go up on the screen, pause the video. Try to work it out on your own. Start it up again and see if your answer matches the one that I have in that video. Okay? If you're still confused after you go through those 3 questions, post a comment on that video. I'll still be up for a little bit longer. I'll have my computer with me, and I'll be looking for some of those questions, and I will do my best to try to respond to you in a timely fashion. Okay? That's really going to be the best way, instead of me just kind of sitting here and trying to do all of this stuff. Okay? So gather your questions, bring them to class tomorrow, check out those videos. Okay? So just kind of wrap up here everything that's on the test. Okay, so 25 multiple choice questions, 3 points each. That's 75 points there, 25 points on the free response. One of the questions on the free response is going to be one of those charts where you have to identify protons, neutrons, electrons, atomic mass, isotopic notation, mass notation, all that good stuff. You have plenty of examples of those in the test review packet, plus all the other practice assignments that you've been given. There is one question on these calculations. There's one question on the average atomic mass calculation. There is one E-dot structure, and there is one Bohr model. Okay, so make sure you know your vocab terms, and then just kind of go through some practice on that. Go through your target list. Read through the targets. The only targets that are not going to be specifically on the test is target AM1 about the confirming the presence of subatomic particles, and then also the target 4 about the scientists. Okay, everything else is on there, but remember, it's not as much as it looks. Okay, because that one chart about filling protons, neutrons, electrons, atomic mass, and all that good stuff, that covers like 3 or 4 different targets on here. Okay, so it looks like a lot, but there's really not that much there. But go through those targets, check red, yellow, green. If there's something that's a red, definitely come in tomorrow into class ready to ask that question. If you're yellow on something, then make sure that you ask. Go find a video. So I promise you, every video, every question on this test has a video that's helpful. Okay, go back onto the channel, go find a video, rewatch it. That's the beauty of those videos, is you can rewatch, you can rewind, you can hear it again, post comments, ask questions. Okay, we still got one more day before the test. The test is not until Thursday, so you have some time. Just kind of go with it. Find your questions, come up with your list of questions, ask them tomorrow, and I will do everything I can to help you out. Or you go talk to one of the other teachers before after school. Okay, there's so many resources available to you. Okay, we are here to help. We're not here to make things hard on you. Sometimes I know it looks like that, but we're just here to push you. We're here to help. Okay, please avail yourselves of all the stuff that we're given. Okay, so for the 7 to 10 of you who have stayed with us throughout this entire live stream, thank you so much for making this time worthwhile. Hopefully that was helpful. Feel free to post questions or anything, and I'll get back to you. You guys have a great rest of your evening, and with that, I will sign off. I'm not Dan, and neither are you. So check you guys later. Have a great night.